What's up, guys? Welcome back. On this video we'll be doing differentiating, guys. We'll be differentiating functions. Now we'll start by differentiating by the first principle, which is very important. But before we do that, there are certain things that I'd like to share with you guys. If it's your first time clicking on one of the videos of this channel, I would like to let you know, guys, that there are other videos on trigonometry, limits, and also binomial theorem. So I made a playlist on based on those subjects or based on those topics. You can go to the playlist part of this channel and try to watch those videos there, because I managed to put them in a sequence order. All right, now here, before we start though differentiating by the first principles, I need to give you some certain definitions before we start, guys. All right, so the first definition that I would like you guys to know is derivative. So derivative is basically the gradient of the curve at any point, or the gradient of the tangent to the curve at any point. So basically the word derivative, it just means gradient, right? And then we have what you call differentiation. So what is exactly is differentiation? So differentiation is the process we use to differentiate, to find the derivative of the function. Now we have two different types of differentiation. We have differentiating by the first principle, and we have the standard differentiation. So we're going to start with the differentiating by the first principle. Now when we differentiate by the first principle, there's an equation or an expression that we're supposed to use in order for us to do that. So the expression that I'm talking about is as follows, which uses limits. So you're gonna be f of x prime, and then it's gonna be f of x plus h, and then plus or minus, in fact not plus, guys, minus f of x divided by h. So limits, and then h approaches 0. So this is the formula. I think you've seen this formula before, guys. So we use this formula to derive by the first principle. So when they say to you derive by the first principle, they are expecting you guys to use this formula to derive. All right, so how does it work? How exactly do we derive by the first principle? Now here's what we do. You'll be given a function which is going to be f of x. Let's say your f of x is going to be 2x minus 1. Now if your f of x is 2x minus 1, already, as you can see here, this is your f of x. So meaning for this part here we are fine, because this is always given to us. As long as there's f of x, you're going to substitute it there in the formula. What you need to find, or what you need to calculate on the side, is f of x plus h. So your f of x plus h is going to be 2, then f of x plus h minus 1. All right, let me explain what is happening there. So f of x plus h, basically what happens here is wherever there is x, we substitute with f of x plus h. We substitute in fact with x plus h, not f of x. So wherever there is x, we substitute with x plus h. Very simple and straightforward. Then from there we just simplify it on the side, f of x plus h. We simplify it here on the side. When you remove the bracket, you're going to have 2x plus 2h minus 1. So as you can see, this now is your f of x plus h. This expression here, or this equation here is your f of x plus h. So what is the next step from here? So the next step is to substitute your f of x and f of x plus h to the expression here, or this formula on our left. So let's do that. Remember guys, whenever you are solving this, do not forget that you have to continue right limit and h approaches 0. Okay, very important. So let's substitute. So f of x plus h, which is our 2x plus 2h minus 1, we're going to substitute it here on the first part. So it's going to be 2x plus 2h plus minus 1, not plus 1, minus 1. As you can see, this is our expression here. Now this is going to be minus, remember we have a subtraction here, f of x. So but remember, f of x, it's 2x minus 1. So wherever there is 2x minus 1, you put it in a bracket here, 2x minus 1, and then close bracket, and then you have h. Guys, please be very careful when you substitute f of x. Remember, f of x on its own is an expression with two terms. Okay, it is 2x minus 1. So this negative here is gonna affect both of these terms, so put them inside the bracket. Now let's continue. So when you continue there, we're gonna have f of x prime. By the way, f of x prime, it's symbolized, or it shows that we are differentiating, guys. Okay, when you see prime there, it means we are differentiating. So limit h approaches 0. Now the first ones of f of x, there's nothing you can do there, nothing is affecting them, so you're gonna leave them just like that as they are. But let's look at the ones of for f of x. We need to multiply by the negative so that you can get rid of this bracket. This is negative 1, by the way. So if you say 1 multiplied by negative 1 multiplied by 2x, you're gonna have negative 2x. There we go. And then if you say negative 1 multiplied by negative 1, you're gonna have positive 1, and then you're gonna write h underneath there. So guys, like I said, be very careful when you do this, because if you don't put the brackets there, then this following step here is gonna be challenging for you. You won't able to find the like terms, because after here we need to find the like terms. As you can see, we have 2x here, we have negative 2x here, we also have negative 1, we have positive 1 here. So this 2x and negative 2x, they subtract each other and they give you 0. This negative 1 and this 1, they subtract each other, they give you 0. So the only thing that we left with there on the numerator is gonna be 2h. So another tip that you should pay attention to, or another thing you should pay attention to, after you have simplified or removed the bracket, the expression or the terms, let me just say, the terms that don't have h, they should subtract each other, and you should be only left on the numerator, you should only left with the terms that has h. If the term has h on it, or it's multiplied by h, that term should be left on the numerator. So let's continue. As you can see here, the one that has h here, it's 2h. All right, so we have f of x prime, and then limit, and then we know that limit h approaches 0. All right, so what are we left with here? We only left with 2h over h. So when it's like this, obviously h divided by h, that is 1 multiplied by 2. So when it's like this, guys, your answer, the limit and the h approaching 0, it's really not that useful anymore, because where are you going to substitute this 0? You can't substitute it anymore. So this limit and h approaches 0, it falls out. So your answer is going to be 2, and meaning that your f of x prime is equaling to 2. So this is your final answer, guys. I hope you understood this, because if you can able to understand how to get f of x plus h, then you know that f of x is given to us. So you have to be very careful, guys, when you are simplifying this. Okay, guys, I hope you understood, and I hope if you didn't understand, please leave a comment in the comment section. Do not forget to like and subscribe to the channel if this video was very useful to you, because I'm gonna make more videos where we are differentiating by the first principle with an x to the power of 2, with x to the power of 3, and more. So subscribe to the channel, and I will keep on making those awesome videos, and keep on watching this video. So this is gonna be part 1 of the playlist where I will be differentiating by the first principle. So thank you very much, guys, for watching. Till next time, cheers.